can headphones be hard to drive?
This is a question of endless debates on the internet, and it seems to be a lot of confusion and misleading statements surrounding it.
No way. Misleading?
That's so unlike the internet.
Yeah.
Yes. But there's a few things to think about here, right? You always see people talking about the sensitivity of the headphones or the impedance, and they never seem to like mingle them together, or that's the confusing part, how they work together. Because it's not necessarily that sensitivity matters. And impedance doesn't always matter either.
Yeah, well,
they both matter.
Yeah, well, I think the first thing to do is probably just generally explain each of those things and how it matters. And then maybe we could put them together in the end and find out they're both one and the same. Okay, so since we'll break this into two parts, we'll talk about efficiency and we'll talk about voltage. So let's start with efficiency. And what does efficiency mean in a headphone?
It's a number you see a lot, and I think it's misused a lot too. It's shockingly simple to understand, but there's some implications that make it more challenging. Efficiency is straightforward. It just tells you the power you need to make a certain noise, a certain amount of volume. So you
Out of that speaker, out of a speaker,
right?
in this case.
So the higher the
Or a
number
headphone.
in efficiency, it means the more volume you get for the same unit of power. Now you might think that makes it easier to drive if it has higher efficiency. And that's where it gets difficult, maybe.
The deal with efficiency is it's considered, it's a number in dB that represents how much volume you get out of a speaker with 1 milliwatt of power being applied to it. So it doesn't matter what the impedance of the speaker is.
Right.
Could be 50 ohms, could be 500 ohms, right? You're putting 1 milliwatt of power into that and measuring how much volume it makes, and that's efficiency. So, you know, it is easy, like you said. It's kind of an easy number to understand. I'm putting this much power, I get this much volume out, right? So now where it gets confusing is the second rating on speakers is impedance. That's where it gets a little confusing.
And especially because you often see fairly high efficiency headphones that can be high impedance. And so you think, oh, it's efficient, it's easy to drive. Well, no, not necessarily, because you still need to deliver power into the headphone. And the amplifier's job is to do that.
Yeah, well, that's where it gets confusing. As you increase impedance on a speaker, as the impedance goes up, so let's say a 50 ohm speaker, 100 ohm, 150 ohms, to put 1 milliwatt of power into that, you need an increasingly higher amount of voltage to put 1 milliwatt into an increasing amount of impedance.
As an example, on a headphone like this, roughly 50 ohms, it takes around 0.2 volts to be able to deliver 1 milliwatt into this driver. If it was 150 ohms, it's closer to around 0.4 volts.
So 3 times the impedance, going from 50 to 150,
Double the voltage.
requires
Roughly.
double the voltage to put the same amount of power into this to give you that dB specifications for sensitivity. So you can see where you run into issues as you go up in impedance. And that's 1 milliwatt.
Right.
No one listens at 1 milliwatt.
Well, very little.
So let's say you're listening at 10 or 20 or 10, 100 times that.
250,000.
Yeah. Well, not that well. You see where the problem is, right? if it takes at 150 ohms, if it takes 0.4 volts to give you 1 milliwatt, then it's a linear thing. So it's going to take 4 volts to give you 10 milliwatts, 40 volts to give you 100 milliwatts. You can see where you start running into volt. You run out of volts, right? The amp's going to run out of volts.
Particularly with portable stuff, that's usually the problem.
Yeah, portables don't have voltage. They run on batteries,
Yeah.
so they're quite limited. So I think I don't know if it's easy. It's difficult to follow, but so you're given a specification for a sensitivity rating at 1 milliwatt. So 1 milliwatt isn't where people listen. That's really low amount of power. It's 1,000th of a watt. So okay, so if we need 0.2 volts to get 1 milliwatt into that means you need 10 times that to get 10 milliwatts into that, or you need 2 volts. And if you wanted more, 10 times that, you need 20 volts. So you can see where the problem, where we run into where you're like you said, with the portable gear,
They usually run out of volts.
yeah, they don't have 20 volts. The battery isn't 20 volts. They don't have that kind of voltage put out. So it's tapped out. So so that's where impedance starts to cause a problem, where the sensitivity, like you said, might be high, so that it's uber sensitive with 1 milliwatt going into it, but you might need a lot of volts to get that 1 milliwatt into it.
Right. So everything always has a limitation, right? And if you have a high impedance headphone, it tends to be an easier load on the amplifier, but it tends to mean it's not easier to drive. Oftentimes you need more voltage to get the same volume level out, but it also depends on the efficiency. That's where it gets complicated. So it really depends on what amplifier you're pairing it with. But there really aren't that obvious intrinsic rules for what's easy to drive. It depends on what you're plugging it into. If it's portable, typically you want to be lower impedance. It's easier to get power portably with lower impedance, and as a result, then lower voltage requirements. If you're desktop, now you're less limited to usually. It's often easier to get the voltage desktop, but you see a lot of gear that isn't as powerful. It doesn't need to be more or less powerful, it just oftentimes isn't.
Well, and the reason that why desktops are more capable is because they're plugged into 120 volts of a wall, or 240 or 220 if you're in Europe. And so
Limitless power supply, sort of.
Right.
And efficiency be damned. You don't care.
Right. I mean, obviously there's small desktop amps that might run into the same problem as a battery operated. And usually those are defined by having like more of a wall wart power supply, where tabletop supply, where the supply is just a thing you plug in a wall, and it just, the smaller amps tend to use it because they don't need that much. They're not made to power headphones that are more demanding, or need to be driven harder. And I guess that's the word when people say drive. It's just kind of like being you're driving power into the headphone, and so it's a combination of how much voltage does it take to drive power into this headphone versus how much voltage to drive power into that headphone, and to make it more complicated, right?
Well, that's what we need.
Yeah. At some point, the amplifier itself, whether it be battery or desktop, has a power supply, the thing that runs it.
It supplies power.
It supplies power, yeah.
That at some point will run out of power. It
Right.
just runs out of power. So you could have gobs of voltage coming out of this amplifier, but at some point, the power supply says, chokes. I can't give you any more. I could give you the voltage, but now you start lowering the impedance of the headphone. Let's say the headphone's got a crazy low 16 ohms, right? And you plug it into this high voltage amplifier, it chokes because the power supply can't drive that high voltage into a low, hard to drive impedance. And that's where the confusion runs in. And it's the opposite extreme too. When you have a headphone with a high impedance, let's say 600 ohms, right? You got a power supply, beefy power supply in an amplifier. Puts out power like crazy, but it doesn't have the voltage. It doesn't go as high in voltage. So it can't drive that really high impedance. It doesn't have the drive to put the power into a really high impedance. It needs higher voltage to put the power into the high impedance. Does that make any sense?
Yeah.
Sort of, but it's very confusing.
Look at its height. Voltage is height. Voltage is potential. Back in the day when we learned in school, right, electrical class, voltage is potential.
Yeah.
How much potential do you have to create power is voltage.
But which one do I want?
Well, that's the confusing part. What do you really need? Do you really need it? What do you really need to drive your headphone?
So I guess it comes down to, it's not that any particular headphone is hard to drive. It's just that you need to match the headphone with the appropriate amplifier to drive it.
It helps.
Yeah. So basically with Diane MR, that's what we did. And I assume a lot of other vendors do the same. We looked at the market and said, okay, what is this headphone supposed to do? What market is it supposed to be used in? How are people going to drive it? What are they going to plug it into? And then we tailored the design of the driver around that so that it's easier for people to drive it in the situation they're likely to use it in, right? So we're sort of guesstimating how it's expected to be used. And then we match the impedance around the expected thing it's going to be plugged into. But that's really just what you got to do. You got to match the amplification with the headphone and the demands of the headphone.
Yeah. It's basically a two-way street. I mean, you can't play one without the other. You have to have an amplifier that's capable of dealing with that sensitivity and that impedance.
It's got to deliver the right amount of power into the headphone.
Yeah.
And how hard that is depends on the headphone and the amplifier.
Now, you could just go out and buy the biggest goddamn headphone amplifier there is, right? Some people use speaker amplifiers.
I mean, yeah, that's the brute
Yeah.
force way. Yeah.
And chances are, if you go with a speaker amp, you got it all.
Current. Yeah.
Right. Then you run into the other problem. Now it's hard to drive extremely sensitive, easy to drive
right.
headphones.
That's the problem because big power amps tend to make a lot of noise.
So the volume's like barely up and it's deafeningly loud.
Yeah, right. Yeah.
Yeah, so that's a different problem too. But usually it's not a huge issue for most people.
We had that happen the other day. We had one of the guys, Norm here, brought in this Eris headphone that Zeus is putting out, and it's rated at what the hell is it rated at?
118, I think. Yeah.
118 dB, which is stupid sensitive. It's like not much gets that sensitive. So it only needs a little tiny amount of power to play full volume. And and we hooked it up to our typical amps we use here.
It was a Broadway.
Broadway. It's not
2 watts.
It's kind of in all respect,
Not even.
watt and a half.
Yeah.
Right? And you crack the volume control, and this thing goes full. So it's like, well, I mean, so that's one example of a mismatch, right? Where it's like the amp has got too much volume, too much power, too much voltage, however you look at it, for such a high sensitivity headphone. And so you really, it's unusable. You don't have any range.
It's very hard to get the volume right.
We should have had a S.
Yeah.
Broadway S.
Well, yeah. And there's ways to do that. I mean, some amplifiers have gain settings, so you can turn the gain
It does.
down.
We didn't turn it down.
Yeah, we didn't touch it.
Yeah.
Well, we didn't need to. I mean,
Yeah.
we know what we were doing.
Yeah.
We just wanted to hear it. But the bottom line is that in a normal practice, you wouldn't want to play like that in home. You want to actually be able to use the volume
match,
control to be able to, for different music and movies and whatever. So bottom line is that that's what you're looking at. And the same is true with like something like an AB 1266, right? It's a nominal 50 ohm impedance. It's not crazy. It's in the middle. A lot of amplifiers are designed to work well with that impedance. No problem at all. But it's low sensitivity.
Right.
89, 80, I forget what it is. But it's
So if you want it to be deafening and loud, you need a lot of power. You need an amplifier that can put a lot of power.
Yeah.
Now, 50 ohms, you could drive it on a lot of things. So for this, it's really about how loud do you want to listen, and is it a good match? Is it going to sound good? Is it the right pairing?
Yeah, I mean, we've had people with running on couple watts.
Yeah.
You can
All
plug it into a
kinds.
phone dongle. I've done that before.
It'll work.
It works. It's okay.
But most people prefer like a headphone like this because of its capabilities. It's actually capable of handling more power and playing it cleanly.
Right.
And so you see people running 8, 10, 12 watt amplifiers, which is
100 watt speaker
insane.
amps.
Yeah.
Yeah, right.
Sure.
It's sane for most headphones, but not for one like this. So, there's the confusion. How to use what with what.
And in particular with speaker amps, they're usually rated 100 watts, but that's at 8 ohms.
Right.
So it wouldn't put 100 watts into that headphone.
The divisor, if you're going into 50, is like 5 or 6 times. Yeah. So, 100 watts into 8 is like divide by 6. Let's say it's like 15, 20 ohms into 50, which is still a hell of a lot.
It's a lot.
Of power.
Yeah, 15, 20 watts.
Yeah, it's a hell of a lot of power.
At those levels, you need to consider what the power handling is.
Well,
Because
yeah,
it doesn't necessarily mean if it's sensitive, it doesn't handle power, and if it isn't, it does.
Right.
I mean, they're sort of aligned, but it's complicated. That's a future video for sure.
It is complicated, but
It's unfortunately complicated.
But that's why you need to get with your dealer, you get with the manufacturer of the headphone, and ask them like what's if it isn't obvious on their website or they don't make recommendations.
what do I need?
Ask them, or see what other people are using with it that they like. That's the shortcut. It's a shortcut. You don't have to deal with formulas and figuring this all out.
Yeah.
Ask somebody
just
knows.
try it too.
Yeah, ask somebody who knows. Or try it. Or
And sometimes
trial
the
and error.
statistics you see on websites for amplifiers can be a little optimistically rated.
Yeah.
So it's a little harder to do these guesstimations
True.
with that. And sometimes they're really conservatively rated, which is not really better.
Yeah, some amps say they're 10 watts, which they might be in the I don't know what.
Yeah.
But they sound like a 2 watt amp. I can compare it to a 2 watt amp, and they both sound just as loud. So what is it? And again, there's the problem, right? What impedance is the headphone, and blah blah blah. So there's no easy answer to this, unfortunately. That's the way speakers are. It's the way audio is.
Yeah. I mean, your example of power supply running out, it always reminds me of my receiver at home. They rate it like 115 watts a channel, right? You're like, oh, cool, that's plenty. Times 7, right?
Yeah, right.
But it can't do that. Asterisk, that's one channel I could do that on. And if all the channels are trying to get 100 watts, it just shuts down because the power supply runs out of power, and then we can't do it. So
usually you go by weight on stuff like that. Nowadays you got switching power supplies.
So throw that right out the window.
Yeah, I guess. Yeah. Back in the day, we went by weight. The bigger the supply, the bigger the transformer, the heavier the receiver.
Yeah.
But now, all bets are off. Can't tell. But yeah, in general, you could also go by how much you spend too. A 300-watt receiver.
Power's getting pretty cheap these days, though, so that's falling apart too.
That's true.
Power doesn't intrinsically have a high cost. It's just high power that also is good tends to be challenging.
That's true.
And that's especially a problem with a receiver, because then if you need 7 good high-powered channels, well, it's not going to be cheap.
Yeah, and the same holds true with amplifiers for headphones. When you get at a higher level of resolution where the headphone really can show you what the system sounds like, it's kind of critical not only to have power, but to have clean power, refined power. And that's, again, it makes it, as you go up into the higher end of things, refinement is an art.
Well, and you probably want
design.
Overhead too, because you don't want to just have it, it's full volume now, because that sucks too.
Well, that's another thing too. People will recommend, this headphone, if you played this at 2 watts, it would be 120 some dB. Who the hell does it? But the reality is you're not playing it at that level.
Right.
You're giving the amp the capability to do musical peaks without sounding like it's dying when the music peaks. And that's a whole different, it's a dynamic thing. So, I mean, to summarize this, all right, because I mean, a lot of people will get lost with all the BS in between, but let's look at the extremes and call them out, and then people can figure out what's in the middle, right? So we have low sensitivity headphones, like most of ours are the lower sensitivity. They need some power to make volume, right?
Well, the worst case would be low sensitivity, high impedance. Very challenging to drive. Not to say you can't, but the pairing of the amplifier you need is rarer. It's hard to find the right one. And you could do the opposite. You could have high sensitivity, low impedance. So you think, well, that's easy to drive. Yes, but it may be too easy to drive. Now you're in this issue where it's like you could barely turn the volume to a level and it's already deafening.
And we should define what low and high impedance is. Well, low impedance would be somewhere in the 16 ohm range. That's really low.
Or less.
High would be in the hundreds of ohms. That's high. Or above 100, let's say, is probably a number to go with. So, low is 2 digits for ohms. High is 3 digits for ohms.
Something like that.
Let's look at it that way. And
Sure.
So now if you have a 3-digit ohm number, right, you need an amp that could put out a decent amount of voltage. Just need an amp that can do voltage, and that's something you got to ask for, because that isn't a rating they give you, a spec they give you. Voltage.
Not always.
Yeah.
But then if you have IEMs, well, then you can't use that amp, right? Well, some IEMs.
It depends. I mean, because now you're talking about how much noise.
Yeah.
Well, we'll get it. Let's go with that. So now we've described the impedance out. Now with sensitivity, you have low sensitivity, which would be, let's say, 85, 90 dB per milliwatt.
Yeah, things go below that.
Yeah,
too.
right.
Yeah, right. In the 80s, it just needs a lot of power to play. We're talking power.
Right.
It ain't gonna work with a portable. Just ain't gonna work. You need a desktop solution. When you start getting into the mid 90s or 90s and up, let's say the 90s and up, it starts to get easier. You don't need as much power, and above 100 dB or so sensitivity, or 105, 110. Now you run into start running into others.
It goes the other way.
Yeah, it's so sensitive. It takes so little power that noise becomes an issue. Like a little bit of noise, the amplifier might not be perfectly clean. You hear the noise because that little bit of noise, it's really low in level, but the headphone doesn't take a lot of level to play it. So, you hear it. You hear a hum or a hiss or something.
And the opposite is true for a not sensitive headphone, right?
Yeah, like ours being low sensitivity relatively, you'll never hear amplifier noise unless you got a real problem.
Well, yeah.
So
Or tube's bad or something,
So in some senses, a lower sensitivity headphone negates issues with, and I'm not talking like, there's going to be hum. Electronics just generally make noise. Tubes make noise. Electronics have noise. It's usually really low in level to the point where you don't hear it. And the better the designs tend to be. But the bottom line is that noise becomes a factor when it only takes a little bit of voltage to drive a speaker. That little bit of noise voltage will drive the speaker too. Hopefully that kind of explains the extremes. I don't know if we covered it. It's hard to explain.
It's very confusing. You really got two sides of this, and then there's a large middle, right? You got the extremes of ultra high sensitivity, ultra low impedance, and the other side, right? Very low sensitivity with very high impedance. Those headphones exist, and those are very complicated to drive because of how limited the selection you have to pair it with. And sometimes you may even use like a big desktop speaker amp or something where you just need to brute force it. But there's a large middle section that, for the most part, is designed around the stuff that's available. And middle of the road stuff, most of the stuff is going to work pretty good on it. That's something like Dyne-MR. Most of your mid-range, higher power stuff, it's going to work on fine. You don't need to worry about any of these issues.
It's 30 ohms. It's low enough where it doesn't need a lot of voltage. It's, I think, 92 dB sensitivity, so it's not high, but it's not crazy low either.
Yeah,
so you
it's
don't
in the
need
middle.
a ton of power.
Right.
So yeah, that's what it was designed to do.
So your options open up in that middle space.
Yeah.
But in the edges, it gets complicated. It gets quite complicated to find just the right pairing. So that's where it helps to talk with people that have experience with it, the manufacturer, retailer, or whatever, and figure out what you're going to pair this with.
Yep. And that's that. It's just complicated.
Unfortunately, yeah.
But, and again, we are talking, it's not like, I should probably say one more preface this, one more thing, which probably should have said this at the beginning, but you'll hear sound out of all these headphones with any amplifier.
Yeah, right.
You'll hear sound.
Right.
It will play. All right. What we're talking about is optimizing the performance at the higher end of headphones, right? What we're talking about here is optimizing. You're paying a lot of money for a really nice product, a really nice headphone, a good sound. You're after really good music. Sounds like you're with the band. And so, that's where it gets more complicated because we're trying to explain how to optimize the system to be able to really appreciate what it's capable of. And that's where it gets a little more difficult, and that's where you should seek, if you're not familiar with what you're doing, you should seek professional help in putting together a system that works for that. That's it. I think that's about as good as we can do.
Sure.
Thanks, everyone, for watching. Take care of yourselves.